So what is the relation between Vx and V out? So V out equals what? Vx multiplied by 1 plus 9k over 1k. So how much is that? This is what? 10 Vx. Right? This is non-inverting amplifier. We derived this one before. So now we don't know the relation between Vx and V1, and that's why it is asked to find it using superposition. So if I try to find the superposition, I ground this one, the first place. I find the contribution of V1 to Vx, and then I ground Vx and do the same for V2. I find the contribution of V2 to Vx. So in this case, by the way, this is A. So in this case, Vx, let's say star, this is due to V1, or saying that V2 is deactivated. Right? So if you have V2 deactivated, what is Vx, Shabab? And let me even take the star out. So what do you think, Shabab? How much is this? I'm applying voltage divider rule, VDR, right? Because we know the current entering the OPAMP is 0. So as if you have only 2 resistors and 1 voltage source. So how much of Vx now? It will be the voltage source, which is V1, multiplied by 3 over 5. Exactly. This is the resistance over the total resistance. So V1 equal multiplied by 3 kilo ohms divided by 3 kilo ohms plus 2 kilo ohms. Again, Shabab, voltage divider rule, our favorite rule. Okay, make sure you know how to do that and how you implement it. So how much is this? 3 over 5. Now, how about Vx if your V1 is 0? What do you think? So I hope it's clear, Sean. 3 over 5, that's clear for Vx. So V2 equals to 0. What do you think? What should I do? And now I am grounding what? V1. Exactly. I'm grounding V1. If you are grounding or shorting V1, what will be Vx? 2 over 5. Okay. So it will be 2 over 5 V2. So now substituting in the first in the V out will be 10 times this, right? So 10 times 3 over 5, that is 6 V1. So we have 6 V1 from here, plus that's 4 V2 from the other side. You agree with this? Okay, small one. So let's now switch gears to the another interesting application of the OPAMP. And let's find this of the expression for the out over the input of the transfer function here, assuming that this, let's first find it without assumption. So we have 4 different resistors, but then at the end of the day, you will make R4 equals R2, R3 equals R1, because this is difference amplifier. So difference amplifier actually, R1 equals R3, and R2 equals R4. We usually design the difference amplifier to be like that. But let's first have it as is. So to do that, we can apply superposition, right? And instead of having too much of analysis, you can apply as if you have only one input. So you are grounding V2 or shorting V2, and you do the same of V1. Right? So if you are shorting V2, what will be V out? So V out with V2 shorted. So if V2 is above shorted, if this one is shorted, do I have a voltage connected here? No, there's no current, nothing, that's ground, right? So then what is this one? If imagine R3 and R4 are excluded. If that's the case, what is the type of this amplifier? Inverting amplifier. So what is the value of that one? Minus R2 over R1 multiplied by V1. Let me call it V1 instead of VI1. Okay. So V1. Okay. And now the second one, V out 2, and so V1 is 0. And if that's the case, you are now shorting this one here. If you are shorting V1, what will be the gain of this amplifier? Or what is the type of this amplifier? Inverting amplifier. So it is inverting amplifier considering V2. Okay. And now what is, instead of looking to this point here, you can just go and find, relation between V out and this point. Let me call it Vx. So what is the relation between V out and Vx? We derived this equation before. +1, exactly. So that is 1 plus R2 over R1. So I can write this one as 1 plus R2 over R1 multiplied by Vx. But what is Vx in terms of V2? Again, VDR, voltage divider rule. What is Vx in terms of V2? Exactly. So this one will be 1 plus R2 over R1 multiplied by the voltage. Or let me have the multiplier first. That is how much? R4 over R4 plus R3. Right? Okay. Multiplied by what? V2. So that's what you get. And then you can just add them together, right? So V out, at the end of the day, you'll get something like minus, let me have this one first, R2 over R1 multiplied by R4 plus R3, V2 minus this much, R2 over R1. And now, if you say that R1 equals R3, R2 equals R4, which is the case of difference amplifier, there is some difference, right? Multiply by 0 paper. There is some difference. You multiply a voltage and you multiply another voltage, and then you take the difference, right? And instead of doing that, can I make the difference first and multiply? So I don't want to multiply and then take the difference. I want to take the difference and multiply. That's what we call difference amplifier. So you are interested in the difference of two voltages. How can I do that? If you want to multiply the difference instead of multiplying two different voltages, what do you think? By looking to this one here. نعوض بايش؟ أنا باخذ الآن difference, right? I باخذ difference. Then I want to multiply the difference. So I want to have something like this. The something, let's say Vx minus V1 multiplied by x. You want to take the difference and you multiply. And instead of having voltage multiplied by Vx minus another multiplied by V1. Okay? So how can I do that? You make x of the coefficient common, right? How can you make the coefficient common? How can you make the coefficient common? Exactly. Exactly. So if you make R2 and R1, that's the assumption I started with. That's the hint, the big hint there. But I was trying to kind of stimulate your thinking. So now, if you are making R4 R2 and R3 is R1, can I rewrite this one to be R1 plus R2 over R1? Can I do that? And then this is R4, but I am using the assumption here. So that's R2 now over R2 plus R1. Okay. And now this is your V2 minus R2 over R1. That's your V1. So now this one will go with that, right? And you are left with the same common kind of multiplier, so R2 over R1. So you can rewrite this one as V out equal R2 over R1 V2 minus V1. And this is very, very important result. Yes. This is a value. This is your value, design value. You can use 1 kilo ohm, 2 kilo ohm, 3 kilo ohm. It's up to you.
So I make R1 equal R2.
Exactly.
So
yeah, you make R1. Yes, this is a design. I mean, this is your design. If you want to make it that way. I mean, this is general, right? This is very generic.
Yes.
It can be difference amplifier. The difference amplifier is special case of this one, right? But now we are looking into the difference amplifier, and we are interested in the difference amplifier. This is very important, Shiba, by the way. Sorry? Okay. This is very important result, by the way. Usually, if we have two voltages, we want to take the noise out. One way to do that, we want to take a noise out from a signal, very sensitive and weak signal. Usually, we take the difference, because if you have two traces, two conductors or two wires close to each other, they have the same, almost the same noise. تمام؟ بمعنى آخر النويز يعتبر ايش؟ common signal بين الاثنين. يعني هذا يمشي بالنويز وهذا يمشي بنفس النويز. So if I wanted to get rid of that noise, what should I do? Subtract them. So I do the subtraction. I'm taking out the signal. Of course, we are doing inverting the signal before. But let's now focus on the noise. So we are taking the noise out, and then we multiply the signal that we are interested in. Okay? So this is the difference amplifier. And let's work out this problem here for the difference amplifier. This is problem 6. So how can I start with this one, Shiva? This is 6 or 7, maybe it should be 7. Anyway. What do you think? So we are looking to find, we need to determine the V output voltage, the value for the V output voltage, the value of V positive, V negative, the currents I0, I1, I2, and I3, right? All the currents, and even if the R input seen from here. Okay. So what do you think? How can I do this? So this is Rn. Okay, so now it is clear it is difference amplifier. R2 is already, we have R2, this was R4, right? And now it is replaced by R2. So we know the equation of the V out. So the V out for sure, it is what? The gain or R2. Let me just put the R2. So it will be R2 over R1 multiplied by V2 minus V1. What is R2? It is given, right? Yes. 100 over 10. So this is 10 multiplied by V2. How much is V2? 3 volts minus 5. Is it? Yes. And how much of V out? Minus 20 volts. Of course, Shabab, if you have supply or this supply connected to minus 15, this output should be minus 15, cannot exceed that. Okay, but it's not there, it is deleted or omitted, so then we can just use it as S, which is minus 20 volts. Then what else? What we need to find, Shabab? What do you think of the current? Maybe this current is clear, right? I3. What is the current here? I3. How much of that current? We know the voltage, which is 3 volts, right? We can apply this voltage, or we can find the current, because I positive is 0. So I3 is flowing this way. Agree with that? So I can say I3 is nothing but, so I3 is nothing but V2 over R1 plus R2. And now we are getting 3 volts over 110K. And how much is that? That's 2.7, is it? Oh, 27. Yes, micros. Now, if you know the current flowing in R2, can I find the voltage in V positive? Yeah. So what is the voltage V positive? And you can do it in 2 ways, by the way. You can apply the voltage divider rule, or you can take the current multiplied by R2. Let's apply the voltage divider rule. So now we have V2 multiplied by R2 over R1 plus R2. And now we are getting how much? This is 3, 100 over 110. Right? Of course, all of them are Ks, kilo ohms. Yes, kilo ohms. So this is 2.73. What else?
V minus.
V minus. What is V minus? How can I find V minus? Exactly. Because it is ideal op-amp, almost ideal op-amp. I mean, it's not showing there, but we can say, assuming ideal. Of course, our analysis before it was an assumption of an ideal op-amp. Assuming ideal op-amp, which means AD or A is infinite, it means now P positive equals V negative equals 2.73. And if you know the V negative to be 2.73, how much of current I2 is flowing? I1 is flowing. I1 will be V1 minus V negative over R1. And now we are getting 5 volts minus 2.73 over 10K. And that's I1, right? I1. And this is 0.2273 milliamps. 10K, yes. And how much of I2 you think? This is an ideal op-amp. The same, because there is no current entering the op-amp, so this current will flow all the way to the out, right? The output terminal. So this is nothing but the same as I2. And now, what is I0? What is the output current? Exactly, but in negative, right? So it should be I2 in negative. So this is this one also equal minus I0. No. No. If you R2 بيأثر إذا أنك أخذت الفولتج صح؟ So if you take this voltage minus the output voltage, it should give you the same current. So my V negative minus V output over R2 should be the same as V1 minus V negative over R1. Okay? What do you think, Shabab, if I connect a load here? Let me put this one to make it kind of interesting. So if I make a load here, let me call that load or 1 kilo ohm. So now, if you do that, I'm going to solve for the okay. If you do that, what will be the current? We can apply KCL, right? How can I find the I out? Exactly. We have the current flowing through the load. That is how much? V out over 1K, right? And that's in negative value. It should be negative because V output now in negative. And then the current, you can apply the current, then you can find the current if it is flowing into the op-amp or out of the op-amp. Just applying KCLs, right? Now, that current is coming from where? I0. From the supply. شوف يا شباب من هنا في البداية كان الكرنت يجي تقريبا من V1. But if you have a load, then there is another current. It should be supplied or drawn from the from the load. This one cannot give you that much of current. So then the op-amp will give or supply some current, either taking or supplying the currents through the load. Over. So let me take this one out. Yes. If you add the load, الIO بيكون مختلف فقط, right? So then the current flowing through the load, you can find it minus 20 volts اللي طلعناها من قبل over 1K. That is the current flowing through the load. Then you apply KCL at this point. This is the only time you can apply KCL because you know all currents except one, which is IO. Okay. We usually say, Shabab, do not apply KCL at the output because the IO is not known, but we know everything now except IO. Then we can create another equation and find IO. Okay. Okay. So let me find Rn. I want to find now Rn. Our input is the input resistance seen from this side. What did we say, Shabab? By the way, it is showing Rn1 and Rn2. What did we say about the input resistance if you have a voltage input? Can we or should we have it infinite or zero? Infinite, exactly. The best infinite, the best input impedance for your voltage, it should be infinite. By the way, if you have a power, how much of input voltage or input resistance you are looking for? If you want to process the power, this is black box. This is your source. Let's make it very good. And this is Thevenin of your source of series resistance. Then you want to apply this one here. And you want to take the maximum power. احنا في البدايه قلنا the maximum voltage. لما قلنا الماكسيمم فولتج يبغى هذا يكون ايش؟ انفينيتي صح؟ لما حطينا كرنت هنا وحطينا قلنا الماكسيمم كرنت this one should be zero. How about the power? Exactly. They should be equal. So this one, our input, we need our input to be the same as your Thevenin resistance. Because this one will result in the maximum power point. The maximum power point. لو ترسموها شباب اتوقع انك تذكروا هذا الشيء عندك الباور بشكل هذا. This power, the maximum power point actually related to the Rn equals the R Thevenin of your resistance. So it means your input resistance, it depends on the application. Are you looking for voltage, current, or power? Okay. So now this is input voltage, of course, and now we want this one to be maximum. But let's find it. How much of Rn1 you can see from here? How can I find the input resistance from this side? Exactly. عندك الفولتج والكرنت, right? So you can find Rn1. So Rn1 will be your V1 over I1. And Rn2 will be V2 over I2. And I think you can see it. Rn2 is clear. It is what? What is R2? Rn2. The one seen from here, right? Which is the summation of two resistors, which is 110. Okay. Right? How about the Rn1? How much is that? لكن إذا أحد يقدر يحسبها بشكل سريع. How much is this? This is 5 volts over 0.2273 milliamps. And how much? Use the same difference amplifier. So this is the difference amplifier. It has a low kind of, or in the low side, input impedance. We want to solve this issue. What do you think of having two buffers? تذكروا البفر يا شباب؟ ايش كان اهم شيء بالبفر؟ ما كان الفولتج الجين واحد صحيح، لكن هذا طبعا هذا it's not good feature, it is just a feature or I mean let's say definition for the buffer. But the main feature of the buffer is ايوه هذا الكلام اللي يصير ايش معناته؟ It has what? Infinite input resistance. لما نقول اللود ما له effect بالفولتج كلامك سليم، بمعنى آخر it has a very large input resistance. تمام؟ دائما لما تسوي isolation, you want to isolate the input from the source, you want to use a buffer. And this is the same way. This is the same difference amplifier اللي كنا عملناها قبل. احنا بس شبكنا عشان الانبوت resistance is low, then you add two buffers. Why? جاك واحد قال بما انك ربطت OPAMP انا بدفع عليه صح؟ هذا power active element. So then you need to, there is some power budget. So if I am using already an OPAMP, why not to use it as another amplifier? Another amplifier stage. Can I use this one as an amplifier stage? تذكرون ايش هو كنا نسميه؟ Non-inverting amplifier. Can I add resistor here and another resistor here? Right? I do this the same here. Am I affecting the input resistance of my system? The input resistance stays the same, right? About infinite. But now I am adding what? More gain to the circuit. So let me call this one maybe R2 and R. Let me just follow the same. I'm not sure how R2 and R1. Yes. So let's give this one. This is, and we are using this. So this is a buffer, and this is how it evolves. I need you to know how the instrumentation amplifier, we call it instrumentation, because it can detect very, very small two voltages. Okay? And by the way, واحدة من الابلكيشن اللي موجودة فيها instrumentation amplifier يقينا الاي سي جي سيجنال. الكترودز لما يشبك عندك الكترودز يشبك كم؟ 12 تقريبا 9 إلى 12 الكترودز على الصدر على اليد ان شاء الله تمشي تمر بالتجربة. This is the way. And then we are making a difference of voltages. Okay. Then we can process the signal to give it the ECG signal, the get and the short. If you have some other very small signals you want to find or you want to measure, this is an instrumentation amplifier, and it comes with an IC. You can buy it as an IC, like the 741. Okay, we have it in the lab and we have it in the eStore if you want to use it. And inside we have 3 different OPAMPs. I don't want to scare you with this circuit, but this is the main circuit and it evolves from the difference amplifier that we derive. So this difference amplifier, we just add 2 buffers that we know. Then جاء واحد سأل نفسه قال بما انه انا اضفت 2 amplifiers 2 buffers ليش ما استخدمها كامبليفاير؟ فاضاف لك ايش؟ 2 resistors. Right? Can you see this now? Can you give the voltage here يا شباب at this point? At this point, can you give the voltage? This is what? What is the type of this amplifier? Non-inverting amplifier. We know the equation 1 plus R2 over R1 direct. And then what is the voltage related to this one? You just multiply this by what? Minus R4 over R3. This is negative, right? So then the problem, another problem, I mean, this is good. Now we have very high resistance. We don't have any problem with that. We have high differential gain because now you are not only amplifying with 1 stage, you are amplifying with 2 stages. Okay, so it means like the gain of this one multiplied by the gain of the second one, right? If you want to write that down, let me do that in the board. So what is the gain of this amplifier? You want to write that. So we have V out. What we know about the difference amplifier? This is the 2 different voltage, right? Different voltage between the 2 terminals. So what is the gain of the difference amplifier? Which is the difference. I mean the gain of the amplifier. It is R4 over R3. This is what we found. So R4 divided by R3 multiplied by the voltage at this point minus the voltage at that point. And now we can see the gain here is the same as the gain there. So we can take them as a common factor. So now we have 1 plus R2 over R1. And the voltage is R, V2 minus V1. So instead of having only 1 amplifier stage like before, من قبل كنا نستخدم ايش؟ difference amplifier عندنا فقط R3 على R2. R4 على R3. الآن عندنا ايش؟ 1 plus I mean this is another stage. يعني تخيل لو عندك هنا 10 وهنا 10 طلع عندك ايش؟ 100 instead of 10. But you are paying that off by using 2 OPAMPs. Right? So now, the problem here with this one, with this amplifier, it also this stage is about it amplifies the difference. I mean any signal, right? It takes any signal of the output too. صح يا شباب؟ يعني معناته لو عندك الفولتج هنا مختلف عن الفولتج. I think I have another good example. Yes, this one here. So we have 2 cases now. Either you do it this way اللي هو اللي قبل شوي. عندك عبارة عن ايش؟ عبارة عن voltage amplifier with 2 stages. الستيج الأول يعطيك 10 والستيج الثاني يعطيك 25. This is 10 and this one 25. So you are multiplying 10 by 25. That makes sense? The total حقك كم؟ 250. 250. Now you are taking the difference before the 2 stages. So if you are taking the difference before the 2 stages, now that difference will give you what? Will give you 0.01, and you multiply by the 250, and you don't have any problem. There is no saturation. So if you can isolate this one from that, you have the same V2 minus V1 and multiply by the gain. Okay? The problem with the second one, actually, that you are multiplying the whole voltage, right? So you are multiplying the whole voltage at this point, and then you are taking the difference. So imagine that voltage is 10.03. 10.03 multiplied by 10, that's 100. And the system will saturate. So ما راح يعطيك 100, راح يعطيك VCC. And then the same here, 10.02. You are interested in the difference اللي هو ال O3 وال O2. صح؟ احنا نبغى ال O1 هذه اللي بنطلعها. ال 10 point something هذا common signal انا ما ابغى. لكن هنا you cannot. So now we are taking the difference with two voltages, the same voltages, and this one should give you zero. The previous case is the one that we are looking for. Now, to solve this problem here, this issue here, what the amplifier who invented the instrumentation amplifier did, it's just very simple solution, just lumping these two resistors as one resistor instead of having them in two different grounds. So this is what is the solution. And if you do this, you are sure that you are taking the difference, then you are amplifying. Okay? Not amplifying the first state, then taking the difference in the second state. Tamam?